please put it in the chat. Because we have to like some stuff to get over. Get through, please.
Okay. So, hello everyone, and welcome to our first virtual SI session for Chem. My name is Claire. I'm going to be your facilitator today, and
my name is Michael, and I will be your moderator.
And we're going to be switching back and forth between these roles. Okay.
Yep.
So, really quickly before we start, I just want to remind everyone that if you are here, please sign in with the Google Docs sheet on the Chem1A, or I sent everyone a message on Canvas. So if you're here, please sign in using that link with your name and ID number to make sure that you're here and we record that you're attending. Okay? So that's about it for reminders. Here's a really quick overview of all of the topics that we're going to be covering. These topics are going to be, the majority of these topics are everything we've learned in lecture up until now. I don't think we've covered everything, but this is, I feel like this is a really good overview of most of the topics. So definitely not everything, but most of them are here. Okay, so we're gonna start off with Michael, and then he's going to talk about the parts of an atom.
All right, so for the parts of an atom, all of you have to know what are the actual components of it. So as of right now, take out a piece of paper, and I would like all of you to draw out what the element lithium look like as an atom, and please label each component. And also I would like for all of you to state the charges of the particles that make state the charges of the particles that make up the atom. So as of right now, pause the video for about 2 minutes and have at it. We will let those who are seeing the video right now, or attending the session right now, just draw out as quickly as possible, because we have like some more stuff to cover. So, but don't worry, you can come back and watch this at any time and see what you missed or not. All right. So give you all about maybe a couple more. Give you a little bit of time to draw it out and see. Should we move on, or?
Oh, well,
we'll give you a little bit. We'll give you a little bit.
Yeah, go ahead and try out this one really quickly. If you have any questions, feel free to type them in on the chat box.
Yeah. And also, if you do, and also for those who just who tuned on, if you want to or not, you can mute your mics and videos so that we don't see your morning Saturday faces.
I mean, or not. I mean, it feels like if you do turn on your webcam, it feels like, oh, it's like a real live session. But yeah.
Probably.
It's totally up to you though.
Yep. And also, if you have any other comments, there should be a chat box. There should be a chat box where you just type in any questions that you have for the topics that are that we're covering, or any of the previous stuff. Here.
Okay. So what are some strategies
What are some strategies
that you guys have to solve the problem? Michael?
Oh, so buddy, this is our first like real session, so we're kind of like a little iffy on it. But for how I would solve this problem, I would think, okay, I would go to my periodic table and look for the element lithium, and then I look for its atomic number. That atomic number will give me a hint of how many protons and electrons are in my element, and then I look at its atomic mass to see how many neutrons are in it by doing the calculation. So it's atomic mass. This looks weird. So give me a second. So atomic mass unit of neutrons. I can't spell, so we're gonna do our best here. So neutrons is equal to the atomic mass of the atom. Atomic mass of the atom. So atomic mass. This is a little awkward. Minus the number of protons. Number of protons. All right, there we go. Number of protons. So that's how you solve for the number of protons. And then after that, you just think, okay, what is the protons and neutrons make up? What do the protons and neutrons make up in the center of the atom? And what are those particles that are constantly moving, spinning around that center piece of the atom? So once you have all that down, we're gonna move on. If you have any other questions, just please post it up in the chat box, and we will try and answer them. So, all right. This is me also, right? Okay.
Alrighty, so the next topic that we're going to be covering is physical and chemical properties. For this, you need to definitely know what the difference are between physical and chemical properties. And also, how do you know if something is a physical change or a chemical change? So take this moment to maybe look back at your notes or maybe the lecture PowerPoint slides to refresh your memory on what these topics are. After you've done that, let's go ahead and try some practice problems. For these practice problems, we have 5 of them. So please take a moment to just answer if the following situations are chemical changes or physical changes. And to justify your answer, how do you know if it is a chemical or physical change? So I'm going to do number 5 for you all, and then the rest you can do on your own. Number 5 is rubbing alcohol evaporates from your skin. The answer to that is that this is a physical change. And my reasoning for number 5 is because when something is evaporating, that is a change in your state of matter. So rubbing alcohol was initially a liquid, but after it evaporates from your skin, it turns into a vapor. And if you recall from the definition of a physical change, changes in states of matter are considered physical changes and not chemical, because you're just altering the state of the substance and not the actual substance itself. Okay, so let's take like 1 more minute for everyone to try out these problems. And again, if you have any comments or concerns. Oh wow, okay.
Yeah, I got the group chat. So
wow, people are talking. Oh my goodness, this is exciting.
We're fine. We're fine. We're fine.
Okay, so Sammy's saying chemical, physical. Wait. Hold up. Okay, let's see. Okay, good. Okay, nice. All right, so let's go ahead and move on. One of your classmates shared the answers in the chat, so please feel free to look at that to check your answers.
All right, so sorry.
Jesus. Okay, go.
It's me? No, it's
Yes. Wait.
Okay, my bad. All right, so
No, it's me. Oh, Jesus Christ. I'm so sorry. Okay, so another important topic we're going to be covering is density. And for density, you should know the formula for density as well as the units, or what the units are of density. I remember in lecture, Dr. Kelly showed us that one trick where you draw a heart and you cut it in half. That's a good way to memorize the formula of it. For units of density, it's going to be in grams per ml or grams per centimeters cubed. Let's see if I can write that. Okay. So now that we have some background information on what density is, let's go ahead and try out these two practice problems. Number one is, what is the density of a liquid that has a mass of 20 grams and volume of 150 liters? So,
that's supposed to be milliliters, actually. It should be milliliters.
oh, no, that's okay, because like,
Yeah,
it's good practice. Because
yes.
you can't just do 20 grams divided by 150 liters because the units will not match up. So you're gonna have to do something, and if you know what to do, please share with us in the chat.
Centimeters cubed. Can it be?
So, okay, so Jared's iPhone brought up a really interesting question. Density is always, the most common units of density is grams per ml or grams per centimeters cubed. If you want to express density in like kilograms, milligrams, etc., you're gonna have to make sure you change all of your units to match. So I'm gonna do an example. Let's say we want to express it in kilograms, right? If you want to do that, you would have to change the bottom part to match the kilograms part. So in order to get from grams to kilograms, we multiply it by 1,000, right? You would have to multiply the ml part by 1,000 as well. And when you have 1,000 ml, that will leave us with liters. So you can't just have kilograms over ml. That would be incorrect. If you change one part of density, you have to also apply it to the bottom part of density. So hopefully that makes sense. Okay, and then it looks like the answer is gonna be, I don't know.
0.13.
Is that the answer?
Yeah.
Really?
Actually, no, that's not actually
right.
Double check here. There's one for those who have answered 0.13. That is technically not correct, because think about it. How many sig figs do each of your numbers have?
Oh yeah, sig figs, very important.
It's your sig figs. So far, who have answered in the chat, you have given 2 sig figs, but check your question. How many sig figs does 20 grams have, and how many sig figs does volume have? All right, there we go. I'm not going to pronounce names because I know I'm going to get them wrong, but yes, that is correct. The correct answer is actually 0.133 grams per liter. Sig figs always come back to haunt you, but always double check the question. If you have any problems with knowing how many sig figs you use, always just go with what. Wait, but 150 liters can't be used. We need to convert it to milliliters, right? Yes, that is correct. You still need to convert it to milliliters, but I'll say this. If you're having trouble with knowing how many sig figs to put in your answer, you have to just go back to the question, look at what data you've been given, and see which one of those numbers has the least sig figs, and that's what you use to finish your answer. Don't round any of your numbers until the very end. It'll prevent any mistakes. All right, so we're gonna do the next problem. I believe it's in the next slide, or taking over the next problem.
Wait, do you want to do the next problem or me?
Well, yeah. I'll do it. All right. So, what is the density of a cube that weighs 30.0 grams and has a volume of 1 meter cubed? So now that we're going, conversion factors don't count when you're using sig figs, right? Conversion factors do not count when you're using sig figs. That is correct. That is correct. Because when you're using conversion factors, they're actually exact numbers. They haven't been measured. So they do not count. They do not count towards your sig figs. Only your given data will count towards your sig figs. Thinking. All right. So moving on. All right. So for this problem, so this problem is the same thing, but instead of having liters in the bottom, we're gonna have meters cubed. So, and it's gone.
Oh, wait.
All right. So, it's all right. It's all right. So we have density. So we have your rho is equal to, oh, I still can't. The mass divided by the volume. And my line's gone. There we go. So our mass is 30.0 grams. And now our volume is, 1 meter cubed. Right? However, we know that density should either be in milliliters or centimeters cubed. So now we have to convert that. So this would be like the most, how do I say this? This is like probably the most extreme of calculating density, because you have to convert meters cubed into centimeters cubed, or from centimeters cubed to milliliters, but we will talk about that later. So what is the conversion between centimeters cubed to meters? Right now, take about maybe a quick moment to look over your notes or look up on the internet if you want to, of how much is 1 meter to centimeters. Give you a little bit of time to figure that out while I search it up too.
Wait, I already have an answer.
All right. Hold on. Let me just do this too. All right. So there we go. All right. So now we know that we know that 1 meter is equal to 100 centimeters, right? Now what we do is, if we're trying to cancel out units, we always put the unit that we want to cancel out, the unit that we want always on top. Sorry. The unit that we want, when we convert, we always want the units in either the top or the bottom, depending on how we want it. So we want centimeters cubed to be on the bottom. So for this, we're going to put 1 meter on top divided by 100 centimeters. Right? Oh, well, I went off the page. It's fine. So we want centimeters to be on the bottom. But remember, we have 3, this is meters cubed, but we only have meters divided by 100 centimeters. So this is where it gets kind of tricky. What you have to do is you have to cube this whole portion in order to cancel out the meters cubed. Seems kind of a little bit of a stretch, but here, I'll show you how it looks like. So 1 meter, so it looks like kind of like this. I can like write it down just fast enough. Kind of looks like, oh, well. The challenge of using a mouse is awkward. It's fine. We're gonna keep going. All right. Oh, that looks. So all these 3 is the same thing as 1 meter divided by 100 centimeters cubed. All right. So after you do all the calculations of it, your density will equal to, what was it? Oh, the awkward moment. I don't have a calculator. Calculator. There we go.
I got this. Or I put in the chat.
I believe it. To the 30 divided by 10 to the. Yeah, I believe it. All right. So your final answer should be, that looks 3.00 times 10 to the negative 5 grams per centimeters cubed.
Cubed.
Bad at writing on this.
Okay, I already typed it in the chat so they can see it.
All right. There we go. All right. So if you got it, then that's great. If you do not, then just if you don't, then that's all. Then that's all right too. Just we're gonna have to keep on going. We're gonna have to keep on going with all the other stuff. Oh, and everything's gone. All right. So next, we're gonna move on to polyatomic ions. So throughout the semester, you should have probably been familiar with memorizing your polyatomic ions on that sheet that Dr. Kelly gave you. I believe the sheet is located in the files, and it should have table of common ions or polyatomic ions or some sort of folder like that. So go back there and look at it, and also try to think about, which of these ions do I really do not have to commit to memory, and which of those ions do I actually do need to commit to memory? There was a trick for a good portion of those ions where you don't have to really memorize them. You just have to look at another resource that will be given to you. So as of right now, I want all of you to name the following. So what is also all the good ones are on page 124, the lab manual. Okay, thank you. Somebody's actually reading the lab manual. The lab manual has a lot of information that students don't really look or use. But yes, the lab manual also has sample calculations for the lab exam. Hint, hint. So moving on from that, naming ions and polyatomic ions. So name the following ions. What is F minus, Cl minus, CO3 minus 2, NH4? That should be a plus. That should be a plus, actually. NH4 plus. Sorry. Claire, can you help me out? I can type on the. I can't type on the PowerPoint. It's supposed to be NH4 plus.
This one?
Yeah, it should be NH4 plus. Oh no, not sodium. The ammonium. It should be ammonium. Whoops. All right, so this one should be NH4 plus. Sorry, everybody. I already kind of gave it away. It's fine. And
Well, you can type it.
I did type it. I can type it now. It's fine. It's fine. Oh, so it's supposed to be NH4 plus. Sorry, everybody. So name these following ions and figure out their name. And then for a challenge, I want all of you to name these compounds down here. Oh, it's back. Yeah.
Wait, Michael, you have remote control access.
I'm sorry. Hold on. Turn off.
Okay, never mind.
We're just gonna put it back here. All right, put it back here. All right. So yeah. Okay. Did we lose somebody? I think we did. All right, moving on. So what was I gonna say? You can control Claire's screen. Oh wow, this is so weird. All right. Moving on. I lost my train of thought. Oh yeah. So aim to try compounds on your own. I mean, not your own. Try them out for yourself, and we shall. I can't get out of. Oh, mouse. There we go. Perfect. Well, now I can type. All right. So try them out. Let's try them out. I'm sorry, I'm being repetitive with it. Give you all a little bit of time to name them out. And where are we? Okay, that's fine. And now let's move on to the next one. Or if y'all need like a minute, just let me know, or just let us know if y'all need like a little bit, like a minute or so to like finish out the problem. If not, then we're going to assume that, okay, so we have a yes, please. So we're gonna just to type them. Okay, so we'll give people like at least one more minute to at least type in their answers or what they assume which one is which. And yeah, okay. That was my niece, everybody. She just left. She did not know that I had stuff to do, but it's okay. Moving on. Oh, okay. If you're unable to hear us, that's actually kind of awkward. Oh, right. We're supposed to get them. That's fine. Floor. Okay. 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 All right. We're getting some feeds in. So, yes, those are all those ions are all correct. All right. We'll try to speak louder because we have how do I say this? Bad mics, or not mics. We have no mics. That's the awkward part. Oh, we got potassium. Check that. Check what PO4 is again. Actually, wait. You're how do I say this? Double check that. Double check that. How about that? Trying to like not give y'all the exact answer, but more like see how to. Oh, there we go. See.
Wait, what's PBBR4?
PBBR4. Oh, that is. Wait a minute. I was gonna answer it. Okay, so PB and SN, they are. Think about what PB and SN are. What is so special about them? So go back to your polyatomic ion sheet and see what is so special about PB or SN. Like what's so special about them? Oh, can you explain real quick which one needs a Roman numeral? All right, so we have a question about which needs a Roman numeral. So for those who do know, you can answer it right now. If not, then I'll give an explanation for it. For the ones who need Roman numerals are metals that have multiple different charges. So when you go look at the periodic table, which I have in a couple of slides, I want all of you. You will have to know where there's that specific portion that have multiple of different metals. And yes, transition metals are the ones that have different charges, that have multiple different charges. So when you think about it, lead and whatever this is have multiple charges. So they have multiple charges. So when these metals have multiple charges, well, these transition metals have multiple charges, that's when you include the Roman numeral. So try and see if you can answer these two now. Give you all about maybe a good chunk to try to figure it out. And I'll erase this so you can see the again. Go way back handwriting. All right, we're good. So let's see here. See if y'all can figure that one. See if y'all can answer those two. All right, let's see here. Give you about a little bit more time before we move on. It doesn't be simple. So we have a question about how the exam will be. The exam varies, in all honesty. Double check that. Double check here what's combined. Remember when you how do I say this? When you name an let's see. All these down here are compounds, but what kind of compounds are these? What kind of compounds are these? What kind of compounds are these? We'll cover that over in the next slide about what these compounds are. But as of right now, we're gonna move on for a little bit. I'll answer your question about the exam in just a bit. So Okay. So now we're moving on to naming ionic and covalent compounds. So I want to know, what is the difference between an ionic versus a covalent compound? So how do you, then now you have to think about it, like you have to think for yourself, like, how do you name an ionic compound, and how do you name a covalent compound? So now, to answer one of your classmates' questions, the test itself, it varies. It's based on the professor's, I guess this is a stretch, but the professor's imagination. So it can either be very simple or very complex. But just be familiar with at least a good portion of each of the material that you have covered. If you have trouble, then look back at your notes or go over through the textbook. The textbook has a lot of information about how to solve some of these problems, or probably review your homework. At least that way you have more resources to know. And if you feel like you're really, really stuck, then come to talk to us like Monday morning, or not, then go to Doc. And if we are not able to answer it, then go to Dr. Kelly. So Dr. Kelly should be like a after you tried everything. So the last resort, if that makes sense for everyone. So is this a, oh, sorry. So how do I say this? So if you have answered these questions, then you should be ready to name ionic versus covalent compounds. We don't have any, we forgot to give you a little bit of practice problems for that, but if you want some extra practice, just go online and search up ionic compounds or covalent compounds, and then figure out and try to practice for yourself how to name those specific ones. All right, so now we are moving to percent abundance. All right, so I know a lot of students having problems with solving for percent abundance, but that's all right. So like the question is like, how do you calculate percent abundance? Well, I found something online that actually made a lot more sense. So it's this little picture right here. So the atomic mass of an element is equal to the percent abundance of isotope 1 times the atomic mass of isotope 1 plus the percent abundance of isotope 2 plus the atomic mass of isotope 2. So if you like algebra, in a sense, think of it as how do I say this? I'm trying to figure out the numbering. So actually, this might be I might screw that up. So this formula here will help you solve out for percent abundance for those of you who haven't who are still having trouble. I tested it out and it just works. It works definitely. If you have more than one isotope, then you just add in another factor. That's pretty much it. So let me see if I can write it again. So let's see. So we have X. So X is your percent. So you have X percent 1 times the mass 1 plus X percent 2 times mass 2. And then if you have a third element, if you have a third percent, then it's X3 times mass 3. Oh. And this all equals your atomic mass. So that's it. So if you only have 2, then you don't have to do X1 times mass 1 plus X2 times mass 2 to get your atomic mass. And if you have the third one, then you just incorporate that third factor. However, if you were given the atomic mass and the masses of each, then it's just a little bit of algebra. You just have to figure out what is the percent of X of all these little X's. Do you note that when you have, so just know that X1 plus X2 equals X, and you know that in a percent, a percent is always equal to 1. So x1 plus x2 is equal to 1. So when you try to do the algebra for it, you can figure out how to find the other percent of the molecule. You only have to know how to figure out at least, if you're given 3, they must give you at least 2 of the percentages, if that makes sense for everyone. So we're going to move on. If you have any questions, please post them up in the comment, and we'll post them in the chat box, and we will try to answer them. So now we will move on to the periodic table. And I believe this is me also. All right, so the periodic table, it's your partner in crime. It is your it's the bee's knees. It is your lifesaver. Marry it. I did, and it's the worst marriage I ever had. But moving on. So the periodic table has all this information that will help you out during lab, the test, lecture, any problems like that. But you just know how to read it. So right now, I would like everyone to take out their periodic table and label the following. I want to know what is the charges of the groups that you know, and also name the groups that you know, and also I want to know what are the charges of each of those groups. So what I mean by that is, so for this first column right here, this first column right here, I want to know what's the name of it, and then the charges that are associated with it. The second column, I want to know what's the name of it, and the name of the column and the charges with it. What is this big portion here in the middle? And then for B, C, N, and O, you don't have to know the name of it, but just give me the charges of each of those columns, and then know the name of this column, which is this column all the way over here, the name and the charge, and then these the big 6 over here. So go ahead and go ahead and then fill out the periodic table. If you still have any questions, please post them up and we'll answer them. We are doing this in record time.
Wait, are you ready to move on, or?
Give them a little bit. Give them a moment to like search up the periodic table and like list it out.
Okay.
Yeah. So, and then once you list it out, after the session, you can think, okay, so I have all of these. Maybe I should go check my polyatomic ions sheet and see which one of those ions appear on the periodic table, so I can save some brain power or sanity for some other information. If you're having trouble with the audio or us speaking, let us know. Just post it up in the chat box. Or if we're not clear on something, then please also post that too. Oh, that's weird. All right, give you all about maybe 1 more minute for everyone. Or someone can answer, or does anyone still need more time is a better question. Just say yes, no, yes. Yeah. Okay, I like it. Name what for those who have answered, what is this big huge portion name here in the middle? What's the name of this portion right here? This big old portion right here. There we go. So also include that in your there you go. Also include that in your periodic table, so that you know what's so special transition metals. So what is so special about transition metals that we should be familiar with? Not all, but should be generally familiar with. The power of the transition metals. They have that strange Roman thing on the side of like, what's a Roman person? Julius Caesar? I don't know. Their charges can vary. There we go. So know that the charge, so yes, that is correct. So the charges on transition metals charges vary. So that's where you have to put the Roman numeral in. So mainly these guys over here, wait, this big old chunk over here and these little monstrosities over here. Let's see if I can find let's try blue. These little monstrosities over here, I believe, or like, I think, yeah, these three. Yeah, these three over here. Or at least these two. Sorry. It's these two. Not this guy. Or draw that again. These two over here. So tin and lead over here. They also have various charges. These two. These two. So lead and tin. They also carry various charges, which includes them in the periodic table. But I think we covered that, all of it. If anyone needs more time, speak now. All right, I guess we're moving on. All right. All right.
Okay. Alrighty, so your next topic, or another topic that's going to be on your exam, is percent composition. And for this, you basically need to know how to calculate it, and also what assumptions do you need to make. So for the assumptions part, it's basically, percent composition is basically parts of a whole. So in order to assume that you can calculate percent composition, you need to assume that, oh, these elements are the only elements within that compound. So let's try an example. What is the percent composition by mass of ammonium ion, or ammonium, in ammonium phosphate? So let's go ahead and take a couple of minutes to figure out how to do this. Again, if you have any questions, type them up in the chat box. I'm gonna do it too because I don't know the answer yet.
Do it also. I'm bad with math. Famous last words.
Okay, a lot of people are, but we gotta try, right? Okay.
Hell, the math.
Oh my god.
I should have not done this in this book, but okay. I got plenty more later. Let's see here. So I need a periodic table. Famous last. That's a famous last words. I need you, internet. I need you in my life. It's just the name, doesn't give me the mass of it. What about this one? What about this one? This one. Oh, this one. Excuse me. Maybe not that one. Oh, here we go. Hooray.
Alrighty, so let's go ahead and try and solve this one. The first thing, or the first step that we need to take is what? You can tell in the chat. Oh wait, we already got some answers. Okay. Okay, so good. It looks like 2 people got 36% ammonium, or ammonia, and that is correct because I got that too, hopefully. But now let's go ahead and talk about how we got there, okay? So this problem is asking for percent by mass, and this is a really good indicator that this is going to be some parts of some mass over the whole mass. So we need to calculate 2 different things first before we can calculate percent composition. We need to know how heavy these 2 are. Okay, so for this, you're going to need to use your periodic table. In NH4, or just NH4 alone, we have 14 plus 4 equals 18 grams. But in NH4, 3PO4, there are 3 of these molecules. So we're going to have to times this amount by 3 to get the percent composition by mass for this molecule. When you do that, you get 54 grams of NH4. So since percent composition is parts of a whole, we need to know what the total mass that this little piece is a part of. And in order to do that, well, we need to focus on that last part, right? So for phosphate, we're going to do 31 grams plus 16 times 4 grams for oxygen. And we have 95 for this part. So 95 plus 54 is 149. So when you divide 54 grams NH4 all over 149 grams of the whole molecule, which is NH4 3PO4, you should get a decimal, 0.36. So this is almost the answer, but since they're asking for a percent, we need to multiply this by 100% in order to get our final answer of 36% NH4. So this is the final answer. Okay. Okay. Alrighty. Let's go ahead and move on. Hopefully, you guys got something similar to that. Next, we're gonna talk about empirical formula and molecular formula. So here are all the steps listed out to find empirical and molecular formula. I highly recommend that you memorize these steps. I mean, like not memorize them like word for word, but make sure that you know the process to do this. Because if you mess up on one portion, your whole answer is going to be wrong. Okay? So let's try an example problem. So we have a compound that consists of sulfur and fluorine. The compound is 77.69% F, and the rest is sulfur. So for this problem, find the empirical and molecular formula. I'm going to do it too. I don't know the answer yet, so hopefully you all can join me. Okay.
And I need to find something right now. So somebody has already answered the question. You have to how do I say this? Believe if you already divided by the mole. I mean, we'll answer that. We'll answer that once we're done. Yeah, once everyone has like a general idea. So let's type it up. So the range for that. So the range for when you have to round. So the range should be the range when you round. The range when you round for empirical or molecular formulas to whole numbers, it should be around 0.85 to maybe like 0.1. So like 0.8. Oh, sorry. 1.1. So if you have a number that's like around 0.85 to maybe like 0.2, I think about 1.2. So let me read that. So around 0.8 to 1.2. If your number like falls between like that range, then it should be okay to round, but that's after you did the division of the least whole mole number. If that makes sense to everyone. All right. So now we have people. So we now have a couple of people answering with the molecular formula, and Claire will go over it right now or in a bit.
Wait, did you make up this problem or did you like find it online?
I did make it up.
Oh my god.
I made it up.
Okay.
Yeah.
Okay, so I got 1 mole of sulfur and for fluorine, I got 5.87 moles. But the thing is that when you're making these numbers whole numbers, you need to multiply all of the numbers by the same number. So you can't just like change. I'm pretty sure you can't just change one of them.
Yeah, it's a multi. Yeah, but when I made the problem, I try to make it like as close as possible to a whole number without multiplying it.
Oh, okay. So in this case, yeah, you should get 1 mole of sulfur and 6 moles of fluorine.
Yeah.
And it looks like everyone or the people in the chat got that.
Yeah.
So that's cool. Let me write that down.
So for any confusion, when I made the problem, I made the second. I made one of the other halves to be close enough to a whole number, so that way you just like round it up. But if it's like, but you have like a number that's like 2.23, and the other one's like 5.78, then that's when you divide. And if there's still like a 1.5 in the end, that's when you multiply. So if it's like in the middle after you do the division of it, that's when you multiply it to make a whole number. But if it's like really close enough to a whole number, then that's fine. If you have like something that's around like 0.75, then I might be a little stretching it. At least around like 0.8 to 1.2, then you can like round up or round down. That's like a good range to be close enough with it. During the test, you'll have more accurate numbers, because when I made this up, it was more like the ideas were just going off the ideas are just going off. Like, okay, maybe I can make this problem like this. But you should have more pure whole numbers when you do the test, and then you'll see it when you have like a number that's like 0.5 after you're dividing it.
Yeah, that's okay. Alrighty, so we have our empirical formula. The next thing we need to do is find our molecular formula, because the new compound has a molar mass of 292 grams. However, our empirical formula, the molar mass of that does not match the molar mass of the new compound. So what do we do? First, we need to calculate the molar mass of our current compounds. And I got 146 grams. To do that, I got 1 mole of sulfur, which is 32 grams, plus we have 6 moles of fluorine, and that's 19 grams. When you do that calculation, you should get 146. Okay, so 146 does not match 292. So in order to find out what our molecular formula is, we're going to take this and divide it by 146. So 292 divided by 146 will give us 2. And this number is special because this is the scalar, or the multiplication factor, that we need to multiply our empirical formula by to find our molecular formula. So let's try it. We have S1F6, and we're going to times every single mole here by 2. So we're going to get S2F12 for our molecular formula. So this is empirical, and this one is molecular formula. Okay, so hopefully everyone got that. Let's go ahead and move on to the next topic.
I believe that should be it, or we have one more.
Alrighty, so the next topic is conversions. For this, you need to be comfortable with these terms, which is what is a conversion factor, what is a mole-to-mole ratio, what is the value of Avogadro's number, and be comfortable with converting between atomic mass units to grams to moles. Okay, so go ahead and try out these practice problems. I'm only gonna do one of the problems with you guys because we're like kind of running low on time. The practice problem I'm gonna do is number 3. So go ahead and I don't know, we're gonna post these on YouTube later. So go ahead and maybe take a picture of this slide so you can have the problems right now for you to look at. But for the sake of time, the problem I'm going to be going over with you guys is going to be number 3, because that one's kind of a trickier one. Alrighty, so how many atoms of carbon are in 0.420 kilograms of butane? And the formula for butane is right there. How do we start this problem? Always start with when you're given a conversions problem, you always want to start with what you have. In this case, we're trying to go from kilograms, which is what we're given to us, and we're trying to convert this into carbon atoms. So we're gonna start our conversion train thing with this many kilograms of butane. So now we need to cancel out kilograms. We know that in 1 kilogram, there are 1,000 grams. So this will cancel out the kilograms. Next, we need to move from grams to moles, because after we find moles, we can use Avogadro's number to find atoms. So next, how do we do this? We need moles of C4. Wait, okay, hold up. I don't have space. Okay. I'm going to. Okay, how about this? How about everyone try it first, and then I will post my calculations onto the slide, because it's really hard to fit all the conversions on there. So how about everyone try it out first? Again, if you have any questions, type them in the chat, and we will adjust them later. For now, probably just try it out, okay? So always start with what you're given.
The YouTube page, I believe that was Virtue. We'll get back to you on that. We'll post an announcement of what the YouTube page was. YouTube page was, because we're sending this to after we edit it, we're gonna send it to someone else, and we'll send you a link for where it is. I think I made a mistake somewhere.
Okay, I'm almost done. Oh my God.
Oops.
Alrighty. How many sig figs? 3.
That depends.
Alright. Let's read the chat.
So far, I might have messed up somewhere. So far we have answers an answer of 4.36 times 10 to the 24. And I believe that should be, okay. It's Carmen. You're welcome, Bree. Actually, okay, now we have 1.74 times 10 to the 22nd.
I got that.
Did I mess something up?
Wait, 1.74 times 10 to the 22nd atoms carbon, right?
I got 25.
0.5?
25. 10 to the 25th.
What?
Did I miss something here?
Wait, I don't know. I don't know.
Wait, let me try something. Did you? I got 25. Wait, did you do 40? I guess we have to double check our math later. All right.
IDK.
Check our math later.
I
don't know how to answer.
Did anyone else get?
Did someone else get 25 or 22?
Is this for the exponent?
Yeah. Did anyone else get 22 or 25?
Hold up, let me upload what I got.
Let's see here. Let me write. Let's try writing it down. Or, oh, you got. Oh, okay. So we have someone that says 25. 1.74 times 10 to the 25th. I believe that's. Oh, so we have someone that's we have someone agreeing with 25. So we have two 25s. Anyone else got a different answer or the same answer or different same answer? Oh, and we're losing people. This is awkward. This is awkward. But it Fortnite, go away. It's fine. It's fine. It's fine. This is the first one. This is our first. This is all new to us too. New to us too. So we will make better versions of our videos like after we take a lot of practice. But of course, the first one's going to be the most jittery of them all. But did we get the drive check or? Oh. Thank you all for carrying and also like tuning on it. But do we have the calculation for it? Actually,
I upload it, but it's not working.
All right. Well, for those of you who are still like around, we'll be holding a extended session on Monday. We stated it at Canvas. So on Monday, it's Monday 9/17. An extended session. There'll be an extended session for Chem1A lab exam. Oh, not lab exam. Lecture exam. Exam 1. Lecture exam 1. Exam. I can't spell 1. It'll be from 4 to 6 in SS 4 to 6 p.m. in SSC 603. If any of y'all have any questions that you want to like to be asked for the lab exam or like probably prior to it, let us know on Monday so that way I can put it in my lesson plan and we can go over any of those topics that all y'all want to cover. Because I have some topics that I do want to cover with all of y'all, but I want to know from your perspectives of what you want to cover, what you do not want to cover.
Wait, okay, I got it. Oh my god.
And feel general about it, or some tips and tricks. All right, so the final answer was. So the final answer to the conversion. Oh, my.
Yeah, so the exponent should be to the power of 25. I forgot to multiply by 1,000, even though I wrote it out. I'll try to upload my work onto the slide soon. But for those of you who are still here, we're going to move on to the last topic we have for today, which is balancing chemical reactions. I know Dr. Kelly briefly mentioned this at the end of lecture on Friday, and the homework assignment that she gave you all was to write a chemical equation for that one reaction she did when she mixed NaCl with silver nitrite. So I'm going to go ahead and go over that equation with y'all right now. First, we need to write our reactants. For the reactants, we had NaCl, which was in solution. So we have to write the subscript aqueous. And then we draw a plus to represent what it was also mixed with. And we mixed it with silver nitrate. And the subscript for this one will be what? If you know, please type it in the chat. Okay. Yeah, good. Okay, so let's go ahead and add that. Because if you remember in lecture, it was she used droppers to mix the reactants together. So a dropper has liquid in it, and you should know that it was an aqueous solution. So that's why we need these subscripts. Very important. Alrighty, so those are our two reactants. So I'm going to stop it there and then draw an arrow to indicate what the products were going to be formed. And I'm going to have to erase this. Or actually, the way we figure out what the products are is with this little rule called innies and innies. I'm going to choose another color. We're going to use a rule called innies with innies, outies with outies. And that sounds weird, but it'll make sense in a moment. So these are the innies, which are the elements that are closest in the middle with each other. This rule will only work, by the way, for elements or reactions with two compounds, which is what we have right now. And then the outies are going to be the guys out here. Okay, so we're basically going to swap partners with each other. So when we form the products, we're going to create CLAG, or no, hold up, AgCl, and the outies, which are NaNO3. We want to put the positively charged ion first in front and the negatively charged ion behind it. That's why I accidentally wrote CLAG, but we can't write that because the Cl ion has a negative charge, so it always has to go after the positively charged ion. Okay. And same thing for NaNO3. Sodium is a positively charged ion, so it'll always be in front. And nitrate is a negatively charged ion, so it'll always go behind sodium. So after this, we need to make sure that our charges are balanced. Cl has a charge of -1, and silver has a charge of +1, so these are balanced. Na has a charge of +1, and it matches the charge of NO3's -1. So the charges are balanced. The last thing we need is these subscripts. So if you recall from the reaction that she did yesterday, who remembers what was formed? Can y'all like type in the chat maybe if you remember? I know it's been a while.
Describe what it looked like.
Yeah, like what did we see? I know it's like really hard to see, but yeah, it's okay if you don't remember.
Okay, foggy. Yes, the cloudy. Yes, that
Okay,
kind of looks like.
awesome, good memory. Basically,
question mark. It's okay.
before she mixed these products together, or she mixed these reactants together, it was a clear solution. But after she added the silver nitrate, it formed a white cloudy solution. So that indicates that a solid was formed. And I know she didn't go over this in detail, but the solid that was formed was for the silver nitrate. And then for the rest of the solution, which was the sodium nitrate, this was aqueous. So this thing, the white stuff that you guys saw, was this compound, this newly formed compound that was being formed. That's why it's going to have a subscript solid under it. For the other part, the liquid part, that was NaNO3. And since it was the liquid part, we're going to use the subscript aqueous to show that it was an in solution product. Okay, so I'm going to erase all this. And I'm going to write out the correct the correct equation. So we started with NaCl aqueous plus Ag NO3 aqueous, and we made our new products, that and that, that and that, to make AgCl solid, and NaNO3, and this was in solution, so it's going to be aqueous. Alrighty, so that's it for today's session. Thank you so much for joining us. We will edit this video, and when we upload it onto YouTube, we will have timestamps for all the topics that we covered. Good luck on your exam this Wednesday. Study hard, and we'll see you all in lecture on Monday. Alrighty? Thank everyone. Okay. Oh yeah, and then before you leave, please remember that you've signed in on our Google Docs sheet to take attendance if you have not yet. But yeah, and then I still need to upload my work for that one problem. All right, thank you all. I'm gonna end the call now. So.
All right. Peace out, everybody.
Goodbye, y'all.